Hey, sorry about that, you guys. So it turned out the memory on my computer ran out. I ran out of memory, and so it caused my video to just stop in mid sentence. Okay, where were we? The ratio numerator to denominator, as far as how fast they approach zero, is exactly 1 to 5. The numerator approaches, say, at a speed of 1, the denominator approaches at a speed of 5. And so in the end, it ends up balancing out at exactly 1/5. Crazy. Well, I just have one more example. It's a good one. Let's take a look. It's the limit as x approaches infinity, the natural log of x over the square root of x. Wonder how this one will play out. So we saw just a moment ago that when we compare the speeds of 2x and natural log going to 0 anyway, there was this balance. But now we have a square root. Oh, and well, x is approaching infinity as well. So let's see here. Okay, figuring out the indeterminate form. Well, what happens with the natural log? The natural log of a really big number is itself a really big number. So the natural log of infinity is infinity. We could tell that from a graph also if you looked at the graph of natural log x. Similarly, the square root of infinity is still infinity. So that is indeterminate. But which one goes to infinity faster? Or is there a balance? If the numerator wins, it's going to infinity. If the denominator wins, it heads towards 0, but maybe there's some equilibrium. Only one way to find out. L'Hopital's rule. So from the top, and you notice, I'm repeating everything, but let's think of that square root x as x to the 1/2. That'll make it a little easier derivative-wise. So limit x approaches infinity, the natural log of x over x to the 1/2 equals, with the L'Hopital, limit as x approaches infinity, and now we have derivatives. Derivative of the natural log x, 1 over x. Derivative of x to the 1/2, 1/2 x to the negative 1/2. Okay. Very nice. There's some simplifying to do, for sure. Okay, so here's how I'm going to go about it. We have a fraction here. Let's think of this whole thing as a fraction. Let's think of that negative exponent as in that denominator with the 2. So I'm going to write it this way. Limit as x approaches infinity. Keep the 1 over x, and think of that denominator, 1/2 x to the negative 1/2, as 1 over 2 square root x. Okay. And then we're going to do our flip and multiply thing. I kind of skipped that step, right? But we can imagine flipping this and multiplying. So 1 times 2 root x, x times 1, we get to here. And it's looking a lot better. Okay. Looking good. 2 square root x over x. Can we plug in infinity at this point? Well, what would happen? Infinity over infinity again. Oh! So we tried to simplify. We still got an indeterminate form, but we know what to do. No problem. I'm just going to think of that as like a brand new limit question and go for another L'Hopital's rule. Okay. So I'll write the L'H a second time. Just now, this is important. Don't write the L'H on every equal sign, right? Only do it at the moment you perform those derivatives. If you're simplifying, those are simply equal. Right, we don't. All right, here is equal. Right, we just simplified. But then when we do the rule again, now comes the L'H. Okay, you probably knew that already, but just to be perfectly clear. Okay, so here's the derivatives. Right, 2. This came from, of course, 2x to the 1/2. That derivative, well, the 1/2 and the 2 cancel out, and we just get x to the negative 1/2. And then our derivative of x is simply a 1. We don't need that 1. Actually, you know what? Let's simplify this. Let's put that in the denominator as a positive exponent. Okay, so again, just an equals. As x approaches infinity, what happens? Well, remember, that is square root x. Oh, I did write that. Okay. Okay, limit as x approaches infinity, 1 over square root x once we simplify everything after our second L'Hopital's rule. Hey, what is this? We have a 1 on top, an infinity on the bottom. 1 over infinity is getting closer to 0. If the denominator is getting really, really big, then that makes the entire expression very small and it's headed towards 0. So in this case, which infinity won the race? Well, it turns out the square root x is heading to infinity faster than natural log x. Although they both get there, this one gets there faster, and so the ratio ends up pulling that limit to 0. Very, very cool. Okay, well, that's it. That's our section. Go check out the homework. How is this related? Why is this even in this in our textbook in this chapter? Well, it's an application of derivatives. But it's also connected, taking limits as x approaches infinity in particular. That's connected to horizontal asymptotes, which is connected to graphing. And so that's kind of the thinking. But me personally, I think of it just kind of as its own topic. And so there you go. All right.